we are going to discuss about cumulative distribution function for a continuous random variable. The cumulative distribution function for a continuous random variable x with probability density function or fx is a function of fx where the cumulative distribution function is equals to probability of x less or equals to x and equals to the integration of fx from negative infinity to x. Thus, the cumulative distribution function calculates the probabilities for a random variable whose values are less than or equals to a certain number. Read the note below. The probability of random variable x less than a is equals to probability of x less or equals to a and equals to f of a. From the probability density curve, the shaded area on the left of a line at x equals to a is f of a. Next, the probability of random variable x greater than a is equals to probability x greater or equals to a and equals to 1 minus f of a. The shaded area is on the right line of x equals to a. That means the probability x greater than a is getting from the total area under the curve, which is 1, subtract with FA. Next, the probability of x from A to B is the same with these three forms. Can you still remember the probability of PDF? Probability at x equals to A is equals to 0. So, the probability get from f of b minus f of a. From the PDF curve, the area under the curve is probability x from a to b. So the area of f of b is on the left at x equals to b, and f of a is on the left at x equals to a. And to get the area, let f of b minus f of a. Example 1. X is a continuous random variable with the probability density function or fx defined as follows. A. Find the cumulative distribution function of x. B. Hence find the related probability problems. And C. Find the value of k if f of k is equals to 0.4. Solution 1a. This is the probability density function given. The real number line shows the interval in probability density function. So, fx equals to 0 is in the first interval of x less or equals to 0. Fx equals to 2 over 5x in interval 0 to 1. 2 over 5 in interval 1 to 3 and fx 0 in interval x greater or equals to 3. I will use table to find cumulative distribution function. Write the interval from the real number line of probability density function. Then find the cumulative distribution function. The cumulative distribution function or fx is the probability of x less or equals to x and will be found by doing the integration of the probability density function from negative infinity to x. From the real number line of probability density function, The cumulative distribution function or fx in interval x less or equals to 0 can be found by integrating from negative infinity to x, and x can be somewhere in this interval. So the cumulative distribution function is equals to the integration from negative infinity to x of function 0. So fx is equals to 0. The cumulative distribution function or fx in interval 0 to 1 can be found by integrating from negative infinity to x of probability density function, and x can be somewhere in interval 0 to 1. So the cumulative distribution function is equals to the integration from negative infinity to 0 for the function 0, and then plus the integration from 0 to x for the function 2 over 5x. Then this is the result after integrating. So the function is x squared over 5. Now find the cumulative distribution function in interval 1 to 3. So from the number line, the cumulative distribution function in interval can be found by integrating from negative infinity to x, and x can be somewhere from 1 to 3. So cumulative distribution function is equals to the integration from negative infinity to 0 for the function 0, and then plus the integration from 0 to 1 for the function 2 over 5x, and plus the integration from 1 to x for the function 2 over 5. So this is the result after integrating. And the function for cumulative distribution is 2x over 5 minus 1 over 5. And the last one of cumulative distribution function is in interval x greater or equals to 3. So from the real number line, fx is equals to the integration from negative infinity to x, and x can be somewhere in interval 3 to infinity. So the integration should be done from negative infinity to 0 for the function 0, plus the integration from 0 to 1 for the function 2 over 5x, plus the integration from 1 to 3 for the function 2 over 5, and plus the integration from the interval 3 to x for the function 0. And the result after integration, the cumulative distribution function in this interval is equals to 1. We can see that from the cumulative distribution function, fx in the first interval is equals to 0, and the last interval is equals to 1. So the cumulative distribution function is given by this is the cumulative distribution function or CDF. Try to answer the probability of x equals to 0.5. So the probability x equals to 0.5 is equals to 0, since x at 0.5 is the area of a line. Next, find the probability of x less than 1. Look at this note. Probability x less than a is equals to f of a. So the probability x less than 1 is equals to f1. In order to find the probability, is it necessary to do integration process that we have learned in lecture 3? No, CDF is actually get from the integration of its PDF. So to find the probability using CDF, we need to substitute the value of x into the function. Refer to CDF. X equals to 1 is in interval 0 to 1. So by using the function of fx equals to x squared over 5, substitute x equals to 1 into the function. So the answer of probability x less than 1 is equals to 1 over 5. Since this is continuous random variable, x is also continuous in interval 1 to 3. So f of 1 can also be solved by substituting x equals to 1 into the function of 2x over 5 minus 1 over 5. Then we will get the same answer. Find the probability of x greater or equals to 2. Note that probability x greater or equals to a is equals to the total area minus f of a. Therefore, the probability x greater or equals to 2 is equals to 1 minus f of 2. So to find the value of f2, check for x equals to 2 in the CDF. So it is in interval 1 to 3. So f2 is found by substituting x equals to 2 into the function 2x over 5 minus 1 over 5. Then solve, so the answer is 2 over 5. Find the probability of x between 1 and 2.5. Note that the probability of x between a and b is equals to f of b minus f of a. So, the probability x between 1 and 2.5 actually is equals to f of 2.5 minus f of 1. To find f of 2.5, let's check in the CDF of x equals to 2.5. We can see that 2.5 is in interval from 1 to 3 with the function 2x over 5 minus 1 over 5. And f1 is in interval of 0 to 1, or you can use f1 in interval 1 to 3 also. Then substitute into the function. So for f of 2.5, substitute 2.5 into the function, and for f of 1, we can get the answer from the previous solution. So the answer for the probability is equals to 3 over 5. And finally, find the probability of x between 1.5 and 4. And this is equals to f of 4 minus f of 1.5. We can see that 4 is in this interval x greater or equals to 3 with the function 1. Whereas 1.5 is in this interval 1 to 3 with the function 2x over 5 minus 1 over 5. Then, by substituting into the function, the probability of x between 1.5 and 4 is equals to 3 over 5. Find the value of k if f of k is equals to 0.4. This is the cumulative distribution function or CDF. K is the value of x somewhere in interval from negative infinity to infinity of CDF, and zero point 0.4 is the value of f at a point of x. Here is the number line of CDF. So K is somewhere here with the probability of 0.4. Let's try an error. On the interval x less or equals to 0, f of 0 is equals to 0. Remember, f of 0 is equals to probability x less or equals to 0, which means the probability from negative infinity to 0 is equals to 0. This is not what we're searching for. Continue until we get the probability 0 0.4. Let's check for f of 1. So f of 1, or probability x less or equals to 1, represent by the green diagram from negative infinity to 1 is equals to 0 0.2, that getting from the substituting x equals to 1 into the function x squared over 5, or 2x over 5 minus 1 over 5, since this is continuous random variable. But the probability 0 0.2 still not reach 0 0.4 that we need for. Now, let's check f of 3, or probability x less or equals to 3. So from the cumulative distribution function, we know that f of 3 is equals to 1. If f of 1 is equals to 0 0.2 and f of 3 is equals to 1, therefore f of k, or probability x less or equals to k is equals to 0 0.4, is represented by the yellow diagram, where k is somewhere in the interval 1 to 3. From f of k is equals to 0 0.4, let the function 2x over 5 minus 1 over 5, which in interval x from 1 to 3 equals to 0 0.4, by substituting k into the function. Simplify to solve for k. Therefore, k is equals to 1.5. For checking, it's true that k equals to 1.5 is in interval x from 1 to 3. Extra question for you. Find the value of k if f of k is equals to 0 0.5 and f of k is equals to 0 0.1. The probability density function can be obtained by differentiating the cumulative distribution function, that is, probability density function is equals to the derivative of the cumulative distribution function. Example 2. The random variable x has the cumulative distribution function given by A. Find the value of the constant k, and B. Find the probability density function. Solution to A. Here is the real number line of cumulative distribution function, or CDF. How to find the constant k? Let's pick some value of x in the interval of CDF. First, let's try for x0. The cumulative distribution function when x0 is equals to 0. That means the probability from negative infinity to 0 is 0. It is not useful in order to find k. Since this is the continuous random variable, the function of kx cubed at x3 will give the same value of f, which is the total probability 1. So equate kx cubed with 1 at x equals to 3. Then solve for k. So k is equals to 1 over 27. And rewrite the cumulative distribution function. Find the probability density function. This is the cumulative distribution function from 2a. The probability density function can be obtained by differentiating the cumulative distribution function. I will show the probability density function in table form. So first, write the interval of CDF from negative infinity to infinity. So first, interval x less or equals to 0, and second is x from 0 to 3, and the last one is interval x greater or equals to 3. Then find the probability density function. So for the first interval, differentiate function 0, and the answer is 0. For the second interval of 0 to 3, differentiate the function 1 over 27x cubed, and we will get 1 over 9x squared. And for the interval x greater or equals to 3, differentiate function 1, and the answer is 0. So we have the same answer for interval x less or equals to 0 and x greater or equals to 3. So probability density function can be written as 1 over 9x squared in the interval x from 0 to 3 and 0 for otherwise.